Alright guys, let's go ahead and configure our LDP protocols. So the first thing we're going to do is we're going to deactivate our RSVP protocols. So let's do that. And we will deactivate the protocol RSVP. Do that on both. Alright, we need to commit those changes. And we're going to go into LDP protocols. And we'll set this up here for set up our interfaces. We're going to disable a management interface. So for LDP, so there we are. We'll put that one, do the same over here. The same on MX2. That. So here we are, we've got that set up. Hit and quit. Alright, so that's our interfaces sorted there. We'll do a show LDP interfaces. There we are. There's our interfaces for LDP. Set. And we'll do a show LDP session. And what we are seeing is we have got a couple of open connections to 192.168.5.1, 192.168.5.4. If we take a look at where they are at on our lab diagram, 5.1 is P1 and 5.4 is P4, so we've got our neighbors set up for LDP. That's up and running. Do the same down here. And 5.3 and 5.6, which is P3 and P6. Okay, so let's take a look at our route. Now that we've got LDP up, we'll show that to 192.168.11.2. And we've got a BGP. Here we've got a couple of different paths down here with two different labels. So these are now LDP signaled label switch paths. One is going via GE000 and one is going via GE001. So what we first of all see is that LDP has created label switch paths through both of those interfaces straight up. And we'll get a similar down here to 19. Oops. So we take a look at MX2's route to CE 1-1, get a similar result with two paths being available through P3 and P6. Okay, so there's our routes. LDP is up, pretty easy to set it up. Let's try a ping through those paths. So we're going to ping CE2 from CE1. Let's see if we have connectivity. There we are, we have connectivity. It's looking good. And we can see that we have sent 4 packets, and we can take a look at our stats. So what we are seeing, actually we're seeing 5 packets, here we are. Oh, we lost one, there we are. We sent 5, we only got 4 back. So there's our 5 packets going through our ingress there, so which is our 192.168.1.2, our ingress router. There's our packets there. If we take a look at the same deal down here, stats, basically seeing the same thing. Okay, so there we are. We're going to what we're going to do. So that's LDP basically configured. What LDP does is it creates a level switch path across every possible IGP path. Essentially, what it does. So what we're going to do is going to go back and activate our RSVP protocol. And we'll commit that change. Do the same on the other one. Commit that change. And let's check our route now to see what we have got. And this time we see we are going through our RSVP signal level switch path. So what has happened then is the active route has chosen the RSVP signal path rather than the LDP signal path, which goes to show that RSVP signaled level switch paths are preferred over LDP signaled level switch paths. Okay, so why is that, I guess, would be the question. Let's take a look at our inet.3 routing table, and that will answer our questions. So we're going to do a show run show route table. inet.3. So what have we got in here? We've got RSVP signal paths and LDP signal paths. The thing that I want you to note looking at this is the route preference. RSVP has a preference of 7, whereas LDP has a preference of 9, making RSVP the most preferred. Also note that there are many LDP paths, but only the one RSVP that we have specifically created. So LDP just goes ahead and creates all possible paths, basically. Creates a complete matrix, whereas RSVP creates the path that we tell it to create. Okay, so what would happen? How can we make the LDP route more preferred? Well, we'd simply go and change the route preference on LDP, and that would then change the route very simply. Okay, and there's a lab on that which you will get to do. Okay, right. So that's basically what we wanted to get to before we get into our constraint shortest path first lesson. So what we'll do is we're going to wrap it up for the day. In our next session, we'll go straight into a lecture on constraint shortest path first. We'll go through and cover the concepts, explain how it works, and then we'll go ahead and then we'll do some labs on that, and we'll run through the labs and just kind of go through and just really, I suppose, just really solidify our understanding of how this works. This constraint shortest path first. This is actually, we're really getting into traffic engineering at this point. So we're getting into how can we control the flow of traffic through a network, through a telecommunications network, through the provider core. So really getting into that MPLS traffic engineering using RSVP with CSPF. So it's pretty interesting stuff. That's our next lesson, and then we'll follow up with the labs on that. So we'll call it quits for the day and let you get stuck into your labs.